Okay, I think we're good to go. We can get started here. We got a few attendees in, and if people filter in, we'll keep on going. So, all right, yeah, let's go ahead and kick it off here. A few minutes after 10. So I'm Kenny with Neometrics Technologies. Today's webinar is going to be on the Creaform Handy Probe Next. So go up here, the actual optical CMM. All right, so the kit itself comprises of the Handy Probe as well as the C-Track. So we've got it kind of sitting over here, a little out of frame. Camera guy, he's going to rotate this around so you can see. So we've got the tracker system, which actually sees my working volume and my part down here, as well as the Handy Probe. And I'll show you this a little more on the actual PowerPoint. But this tracks the part, this tracks the Handy Probe, as well as the MetraScan. We've done a webinar on that in the past. You might see a little bit of it today. But what we're going to do with this webinar, I'm going to come back over here, is we're going to go through this quick PowerPoint. I've got it kind of pulled up already. It's to show you some of the specs of the new system, go over what is new with the system, and we're actually going through a couple of live workflows. So I'm going to come on back around here on the table. All right, and as we go through these, if you go through the webinar, if you've got any questions, just feel free to type them in the chat, and we'll get those answered for you as we go through. So again, I've got my Handy Probe here. I've got the C-Track over here. So what's new with this system? We'll go through some of the updated specs. But one, the big hitters are we have an instant startup. So many people that are aware of the older system, like a lot of metrology systems, there was a warm-up time with the C-Track. We have that, but we can compensate for it. You can start it up and instantly use the actual calibration scale bar to compensate your field of view. So you can start probing right away, and you're ready to roll. The other thing is we have the self-power. I'm going to set this off to the side. The self-power pack for the actual C-Track. So it used to be only made for moving it from one location to the next without having to shut the system down. Now it can actually run the system for up to 2 hours, which is more than enough time for getting any kind of scanning or probing done. You see the system's so fast that we just don't spend that much time doing that work anymore. We also have auto detected targets, and I'll show you that in a little bit, but we don't need targets for this system. I prefer to use them because it does lock my tracker to my reference part or my reference view. So if anything were to move, if the part were to vibrate, if I have to reposition the tracker to gain line of sight, I don't lose reference with my part after I've already started working, which is huge. All right, so other than that, the accuracy spec, we'll go through that, but the volumetric accuracy, now instead of holding it, there's different specs within the field of view, depending on the length. Now they just, certify a volumetric accuracy across that field of view, which we'll get to in a little bit. Other than that, the thing that I like the most is the new shop floor stand. Actually, it breaks down, so the older kit is pretty heavy. It has a turret on it. It's definitely what we recommend because the thing is super sturdy. You don't have to worry about anybody knocking it over or anything like that. But if I had to transport it in a vehicle, it was a little cumbersome. So now you can actually detach. We'll go over. I'll show you what that looks like here in a minute. But we can actually detach that turret and break the whole system down and it's later. So, but yeah, again, if you have any questions about anything, type them in the chat. Other than that, I'll kick off the PowerPoint here. So the system, I've got to kind of run it over here. So the system itself, again, you can see the C-Track on the left and the Handy Probe on the right. Some better pictures than what you've seen here. Okay, so the tracker doesn't do any scanning; it actually just tracks the probe itself. All right. Before I get into that, though, a little bit of background. If you're new to us, I'm with Neometrics Technologies. Again, we've been around since 2003. We carry a whole gamut of different products from 3D scanners to 3D printers. Our big heavy hitter being Creaform on the 3D scanning side, and then Mark Ford is the big rep on the 3D printer side. I actually have our big printer back here behind me. So under software, we use Geomagic Polyworks as well as SpaceClean, and then as well as the Creaform software. So And that's what actually I'm going to work through today is probing into create-form zone VX inspect. All right. Skip forward here. Just a few of our customers. So many of these have this system or the older version of it, or even the smaller kit, the handy scan. So we'll go on through. All right, so optical CMM. So why do we call this an optical CMM? For those of you familiar with a CMM, you have you basically have a big table with a CMM bolted down to it, and you bolt your parts to that table, and you've got this this end probe that's basically a ruby tip probe that touches off on different points. So this is taking that and making it a lot more mobile. So we've got the tracker we can move around. The scanner, the probe is handheld, but we can change this out. If you have a CMM that uses M4 threads, you can change this tip out. We have a probe kit as well with the angle probe, a 3 and a 6 millimeter ruby, and a few other accessories, some extensions and things like that. If you've already got a probe kit with those threads, you can run anything you want in here. Again, here's the kit kind of broken down to you know, the MetroScan and the MetroScan portable workstation you see there on the left. We kind of talked about that in a previous webinar, but that is the scanner that pairs with this system. What we're really interested in is on the right, the mobile workstation. So that's the C-track all packed down, okay? But that's the stand that I'm talking about. And basically, when you go to use the C-track, you lift it up, turn it horizontal, and then you're ready to go. And then, of course, the handy stand on the right. Okay. So some accuracy specs, single point accuracy of this probe here. You can see there 8/10,000ths for 20 microns, so less than 1,000th of an inch. You know, single point with our field of view. Volumetric accuracy. So we've got two different volumes we can work with in the 9.1 meter cubed and the 16.6 meter cubed. I generally just run the larger one. It gives me a huge field of view. And I only give up about, you know, say 0.5 or so, 0.6 of a thousandth of volumetric accuracy. So anywhere I probe point to point across the distance in that huge field of view, I have an accuracy of 78 microns, or about, you know, just over 0.003 of an inch. So that's huge. I can take this anywhere. I can use it on the shop floor. I can use it in a CMM room, whatever I want. And because I calibrate to that environment, and I use my trackers, my target positioning targets, I can hold that accuracy. Okay, part size, recommended part size 3 feet to about 11.5, 12 feet. You can certainly expand it further than that, but that's about the big, the backside of your field of view. Once you get larger than that, your volumetric accuracy spec up to figure out if you can do, if you got a link tolerance that can fit that, or we can actually pair this as well with our photogrammetry kit. So you see your starting price. The difference between the Handy Probe Next Elite, which is this one, and the Handy Probe Next, they look identical. One's just a little more accurate. So and that translates to your if you repair a MetroScan with this, you get the C-track Next. It's the same sort of thing. You get a little decrease in accuracy there. All right. So a few pictures of it in action. To give you a rundown, we've got some buttons on the top here along with the bottom. So you can take your probe either like this, or you can hold it around the base of the probe as well, whatever lets you do what you need to do to get your points. But you can see there we're working on large objects in large areas. In this view here, this kind of bottom left one, you can see some of the magnetic targets there. So he's actually using that. He's actually tracking the side of that aircraft with those targets, and he's probing within that. So with those targets, somebody actually on that aircraft and, having it vibrate, do things like that, and we're not losing reference to it. All right, another quick rundown, just a little more of the system. So we've already kind of seen that, but you've got the carry case for the probe accessory kit, and over on the left side, we've got the target accessory kit. So that's actually where these come in. So these are magnetic targets. These are actually on swivel, so you can put these targets in bushings on tooling and things like that, and have them permanently attached. You can swivel them around if you turn them apart. You get 360-degree scan. So there's a bunch of advantages to that. All right, how the system works. You've got a couple more slides here, and then we'll kind of move into the live system. So you got the C-track, kind of we talked about earlier. The optical tracker itself tracks the probe, tracks the scanner if you have the scanner, and it tracks the part. So if you're in your field of view and the C-track can see the probe, see the scanner, see the part, and you can take data. So very awesome. We don't have to worry about the old days of being tied to a mechanical arm that's subject to vibration and movement, or a, breaking a laser beam between a tracker and probe, and then having to go back and grab it again. You can take this, you can be, I can probe over here, I can kind of do whatever I need to with the probe. As soon as I point it back to the tracker, it's going to see it because of the targets on the probe itself. All right, last slide here. So just should give you a quick little idea of what the volume is that we can work within. So in one single shot, you can see there the back side of the volume on the larger volume that I normally run is 9 feet by 12 feet, so 9 feet high by 12 feet wide. So you can fit most parts in there, or most of a vehicle, things like that. And again, if you need to expand that, generally I'll have targets in my field of view. I'll just turn my tracker a little bit and still see the target, so it still knows what it's aiming at, and it gives me a huge field of view gain. So all I got to do is shift it left or right, turn it left or right, and I can now scan parts 18, 20 feet without much effort there. All right. I'm going to go ahead and escape out of here and pull up my VX element. So again, do we have any questions coming through yet? Anything I can answer?
No questions.
Good to go? All right, cool. So we'll move on to, a little bit of a live probing here. So I know that's kind of what you guys are looking for. So the probe itself, I've got a part here, and I've got some targets on it. I'm not going to worry about shooting the target just yet. I kind of want to show you just how the probe works. So if I want to probe like a point-to-point across a distance, all right, I'm going to click measure. And now if I want to know the distance between this side of the table and this side of the table, come right over here. I've got a probe button on the top. I've also got one on the side. So all I got to do is hold it, take a single point, okay? Now I'm going to come over here, and we're going to do one on this side, okay? And take another point. Oops, sorry, I didn't accept that person. So I'm going to come back. I'm going to come back over here and just accepted that. So I'm going to come back over here, take 1 point. There we go. And when I click my checkbox, I can get that distance just that easy across that table there. So if I need to, I'm trying to reverse engineer something or gather some, gather some dimensions on a part, I can do that very quickly. Again, I can see here, so the dimension across those 2 points is about 72 inches, a little over that. If I want to do something like take an angle, all right, I'm going to do make an angle between this plane and this plane here. So we'll take the probe, we're going to touch it to the part. All right, click 1, 2, and you see the plane building here on my field of view. 3 and 4. There we go. All right, so there's a plane. Now I'm using a 6mm ruby. So what it's doing is it's taking the points and then it's compensating that 3 millimeters in the direction of the edge of that ruby. So extremely accurate. You're supposed to touch the ruby up to it. If you're familiar with 3D scanning, where you're taking a whole bunch of scan data, a whole bunch of triangles, and you have vertices between those triangles. If you're not familiar with probing, a probe is basically that vertex in between all those triangles. So a lot lower resolution scan. Now where it works, where this excels over scanning is if I just need to take a few dimensions where I've got a bolt pattern, I use this mainly for holes. If I got something that I don't need to 3D scan with, I can probe holes a lot faster with this than I can scan them, process the mesh, and then overlay the mesh. I can open up an inspection. I can take a bunch of holes. All right, so in planes like this as well. So if I just need to check a couple of angles on something, I can go right in. Again, just full speed, 1, 2. Now, if you take a point and you move it, I don't know if you can hear that, but it does a double beep. So what it does is it's throwing that point out. So unlike other systems where it actually keep that point, you have no idea whether it's good or not because it's instantaneous. You hit it, you get it. This one will throw that out if you're not staying. So I'm going to go back. I'm going to click another one. Click another point there. Let me zoom out here. Okay. And click my check box. So there's my second plane, and there's my angle between the two. All right. Now, if I want to do a few things, say if this is all I have, if I don't have a 3D scanner, I can reverse engineer this very easily. All right, I can go into our, let me go ahead and hit the home button here and just go right into VX Probe. Okay. and I can make any of these features with a probe. So you can see my screen here. So if I want to make a plane, let's say I want to maybe reverse engineer this part. So I want to make a couple planes and then replicate this top surface. I can click plane. All right. Click 4 points around this plane here. 1, 2, 3. And you can see how the screen follows the probe, so it keeps track of everything pretty easy there. All right, so there's a plane. Now, if I want the extremities, I've already done, these two. So I can hit 1, 2. I'll just do 3 points here. There's one more plane, and then 1, 2, and 3. So now I've got the extreme ends of my part. If I want to do something like I've got a couple cylinders in the top, easy enough to do. Tell it to probe a cylinder, tell it create an automatic axis, and I've got a couple cylinders here on the top. I'll do one of these over here. So we're going to take a point, and then a cylinder. It's a little hard to see on my screen here. On a cylinder, we're basically probing 2 circles. We're probing a top circle and a bottom circle. So this is a pretty small cylinder, but I'm probing a circle at the top, a circle at the very bottom of that cylinder. So we'll push it down into the part. All right. And you can see there it makes a cylinder. So any of these features, once we get done, I'm going to zoom out here. We can come over here to, let's drop down VX probe. All right. Well, we'll take any of these guys. So we got planes. Here we go. So if I want to export these planes and bring them into like a modeler, if you work in SolidWorks, you can select all those features, right click, and say transfer entities to SolidWorks. So I don't have SolidWorks on this computer specifically, but if you have it on your computer, it'll actually put those features directly into SolidWorks, and it'll make them parametric. So you'll have a line, you'll have an extrude to make your planes, and then you can use those to again, parametrically build a model there. So it's a pretty cool function. So that's running actually in VX models. That's freeforms of a reverse engineering program. Again, one thing I want to do, if I want to get this surface here, is I'll do a polyline, and this is a cool function. You zoom in here. So I don't know if this top surface is an extrude or if it's a loft, but I can come in, I can press and hold my probe button instead of hitting it once, and then I can drag it across that surface. All right, you click the checkbox, and that makes a polyline. We call it polyline, so it's a 3D sketch that you can get into one of your modeling softwares. I'm covering here just in case it's a loft. It could be a loft, I don't know. So I'm going to press and hold, drag it across that surface, and now, along with my 3D features, my planes and my cylinders, I now have a couple of 2D sketches that I can dump directly into my modeling software, loft the surface across them, and boom, I got my part. So basically an extruded cube with that surface, cut it off. So that's how you can use it for some quick measurements. If you want to take a couple of really small dimensions between a few things, or if we want to actually reverse engineer the part, we can do that in here. So as far as the reverse engineering function, again, I'm using this a lot for planes, square objects, circles, spheres, anything like that. We call it, solid geometry. So I want to go to an inspection. That's where I'm going to go into now, which is VX Elements, VX Inspect. All right, and I'll kind of show you an actual full workflow of the inspection process. So I'm going to click Close to get out of here. Again, we're in the VX Pro and VX Model interface, and I'm going to do a File New Session. Actually, I should do a File Open. I've actually got a program written for you. So if you're not familiar with inspection programs or doing this inspecting with optical CMMs or 3D scanners, you basically take your inspection software, you import the CAD file of the part that you want to inspect, and you can go ahead and pre-program all your dimensions and your regions and things like that you want to extract. And then once you are ready to measure the part, go ahead and open this up. You just basically click go, and it has you probe everything you need to. It prompts you to scan. It applies the scan and pulls dimensions, so it pulls the real dimensions. So it's a pretty cool function. All right. So I'm going to clear out my targets real quick. So this C-track positioning. So what this is the, I don't know if you can see on the front of the part, but we got targets here. So these are reflective 12mm targets that the C-track is actually looking for. It's the same one that's on the basically on the probe here. But these targets are going to tell it where the part exists. So you see right now, they're kind of out in space away from the part, right? This has no idea where this part is at the moment. So we're going to do that with our first few functions. But first I want to tie into the reference system, these positioning targets. The old way that the C-track used to work was you had to click detect targets, and you had to go in and select your targets, window them in, which was fine, but it was a little bit of a slow process when you were building a large reference line. If I'm doing something huge, like trying to get around a car or a big piece of tooling, it was a little more tedious than what I'd like. Now we can click this auto detect targets. All right, and boom, it's got 6 targets. There's 6 targets on the part, it automatically sees them. What's great about the auto detection mode is you can reel it down apart. So if you target at the side of a large part, you can either reel it down the part or rotate it left and right, and it'll actually pull them all in, all those targets and across the side of that, no problem. So works really well. I really like that function. All right. Now, if I want to get started on my inspection program, you see here I've got this little window down here. And what this has is all my features within my program that I want to probe. Okay, so first couple things, I've got a few datum planes, and after I probe this 3 datum planes, it's actually going to align to my CAD file. So I'm going to rotate this to where we can kind of see it a little bit better. Okay, there we go. And you see I've got a bunch of dimensions pulled on there. So I'm going to click Measure All. All right, first thing it's going to do is ask me to plane 1. So let's do a fit to screen just so we can see what plane 1 is. That's this top plane here. All right. So what I'm going to do is take my probe. I can see right now it doesn't know where the part is, but I'm going to tell it where the part is. I'm going to probe this plane. So we're going to probe 1, 2. I'm going to get a number of points across it just to make sure I get a good plane. So again, just touching that probe tip to the plane. Once I'm happy with my points, I'm going to click my checkbox on my probe. All right, it's going to go right to my next plane. So you see there, it's on the right side of the part. So we're going to right over here, and it looks like it's this plane here. So 1, 2, 3, 4. All right, so there's my new plane. And now when I start to touch this one, you see it. The probe snap up to the part. So click 1, 2, 3, and there we go. Now we're tied to the part. And let's finish off with the 4th point. Okay, so now if I ask for plane 4, I don't know if you can see it, but it's right on the other side here. There we go. Now what these targets do for me is if I go over to probe plane 4, and let's say something happens, something is not, or even my part moves over a little bit, okay? That would screw me up if I were using an older system that wasn't tracking the part. But if you can see, I'll go right back to touching it. All right, we go right to a hole. So I am still perfectly aligned to the part because I'm dynamically referencing it with these targets. So I'm going to come right over here. Let's probe this plane here. 1, 2, 3, and 4. Okay. Now it's going to ask for a 5th plane because I've got a dimension between the base plate and this plane here. So I'm just going to hit 4 points on this one. Okay, and now we're at our cylinders. So I've already probed the cylinder before. I'll probe these 2 basically because I have a dimension between them. So what the software is telling me to do is, hey, probe these features that you told me to probe, and we will pull the dimensions between them that you wanted us to pull those that you want to pull. So get better point there. There we go. All right, there's 1 cylinder. We'll do the other cylinder. Oops, here I slipped out and it didn't take that point. Now, if you move just like a tiny amount and you do that, and you move off the surface and you don't know it, then you're going to get a bad reading. But because I don't have to worry about that, I'm just going to click my checkbox there. All right, so doing the top surface, so let me trace a couple of lines here. If I'm probing this for measurement, a lot of times I've got maybe some regions that I know I need to take points within. So I'll just every however many inches, Or again, I can press and hold my probe button, start doing the scan mode with it, and it's going to take a point every X number. You can either set it for seconds, every millisecond or whatever, whatever your designation is, or across a certain number of, a point every distance. So if I set it for every, quarter of an inch, I can drag it, get a bunch of points there. All right, now I've kind of used the scan mode to capture that surface. Click the checkbox. So I told you we were going to bring the Metroscan in just for a minute. So it's a new Metroscan Black. I've got an actual, I've got a cross section through the side of the part that we're going to pull a dimension on. So I'm going to run and grab that scanner for you real quick.
Got a couple questions on the handy probe.
Okay. Actually, let's do this. I'll wrap this up and then we'll run through some of the questions. Pointed out we've got a few questions here. So, so I've grabbed the Metroscan here. I'm going to zoom in a little bit so we can kind of see what's going on. All right, so this is a small, simple part. So I would probably scan this part, if I had the option, because honestly, I mean, look at that. You can see just how fast it grabs literally everything. All right. Now, if I had a bunch of holes on a bolt pattern, that's a little different. I've got to make sure, especially if they're smaller, quarter inch or smaller, I've got to make sure I've scanned multiple sides of the walls of those cylinders. So, things like that are where I'm going to transfer over in the real world scenario to a handy probe if I have both options. But yeah, just that quick. I'm going to set the scanner back over here. We've got that. So Metroscan, the new Metroscan Black Elite, 1.8 million measurements per second. This is the fastest scanner in the world. So handheld here. So yeah, there we go. We got our scan data. I'm going to go ahead and say accept. Finalize that. Okay, and our measurement's done. So what I was looking for on that is actually a profile cut. You can see it here around the part. So I can go up to surface profile. Let's take a look at what that looks like here. All right. Sorry, cross section. My bad here. All right, so we're going to go into that view. And you can see there, I get a color map of the cross section. I can actually choose add min and max deviation. So you can see there we're out a little bit. That's due to our alignment. So before I go any further, I do want to answer a few questions. So you mind reading them out?
Yes. One, we have, how large a part can you measure in one setup?
One setup, you've got that back field of view is about 12 feet long. So if you can fit a part in there, you stand back a little further because it is kind of a trapezoid shape. If I got a large part, I put that part back into the back of the field of view, and I can get that about 12, 13 foot part, depending on how much you need within that. So yeah, if you need to do multiple setups, or if you've got a longer one, it's really not much more effort. You just, I'm going to target it up anyways if I've got a part that big. So I'm going to put 8 to 12 targets in my field of view. That way, I'm inevitably going to step in between a few of them in the tracker as I scan or probe. So it just eliminates me not having enough targets. But all you got to do once you fill up that field of view is go and turn your tracker and just a little to the right, and you gain, feet that way. Turn it to the left, you gain feet that way. You're still using those targets in the middle of your field of view. So we've done up to 18, 20 foot parts, and it works great.
Second question, does the probe work with Polyworks?
So the probe does work with Polyworks, works with Geomagic, works with Spatial Analyzer. Most of the big name products, Verisurf as well, if you're running that. We like the Freeform software, Geomagic, and Polyworks. That's kind of what we prefer. That's what we carry. But certainly, if you've got something that's able to take a probe, the probe input, we can double check for your specific setup, but normally you should be able to use the system. So that it? All right, cool. So there's our inspection. Now, before I get going, if you need to adjust anything in here, I can kind of take a look at the part, and I can see that I align to this top plane here, this one right here. But obviously it didn't, you can see the top of the part is not lined up. The top of the part is too short. If I were to hide my CAD file, all right, see it's way down there. So I'm guessing if I look at my surface profile, if I click on my surface here, I can see my profile tolerance as called out to my my datum alignment here because I did datum plane A, datum plane B, datum plane C. You see there it's out, what is that, 82,000. So it's out of tolerance. I put a 10,000 tolerance on that, so it's out about 72,000. So it tells me there's something wrong there, or maybe I accidentally stuck that datum on the wrong plane. So what I can do from that point is I can make, what plane was that one? I'm guessing this top plane here is the one that is the one that's probably a little more tied into the tool itself. So I can make that another datum D. All right, and this is why I love this VX element software. You can go in and you can adjust things. And so I can go back to my alignments, by my datum alignment, and select datum D, B, and C. And you see there, that's going to pull it up quite a bit better. It's saying, okay, you're going to have to recalculate a few things, but there we go. Now, if I look at my profile tolerance, so if I go down to my surface, it's still out, but it's only, you know, it's out quite a bit less there. So, but it pulled everything up. I've got my other surfaces and stuff like that. So, you know, we're using the sample part here. I wanted to show you some of the deviations you can pull. Now, once I get done with this, again, I really like this software. I like this probe with the VX element software because everything kind of pairs together seamlessly. So once I get done with my inspection, I'm going to click on my report. Now I've got a few things. So you see there on the left side of my screen, I've got some kind of pre-written headers for my report. You can enter those in. All right. When we say export, let's call it Handy Probe Webinar. I'll put it right on the desktop. And what it should do is going to propagate all these features over to an Excel sheet. There we go. All right. And we can see here we've got our first page with our, you know, our headers, all of our information about the part. We've got the plane one. I put a flatness tolerance on that plane. Okay. There's a snapshot of my datum. So datum A, B, and C. Or I guess that would be, because I changed it, should be D, B, and C, but that's fine. We've got distance 1. All right, and there's our distance and distance 2. There's our distance 2. So we measured the distance width-wise based off these two planes I probed. And I also measured the distance based off of this top plane and this lip here. All right. So cylinder 1, cylinder 2, there they are. I'll zoom in a little bit. We can kind of see what's going on. But I've got a diameter between the two, along with a position of tolerance and you know, distance, the X and Y distance. So all this stuff with the probe and the Creaform software very quickly propagated over surface. There's all of our points from our surface, so you can see how they deviate to that surface. There we go. There's the snapshot, and there's our cross-section snapshot. So that's what we're looking for when we're using the probe for an inspection process. Once I'm done, I just click Add Part. I'd swap the next part out if I got 10 of these to do in a day. I got my probe ready. I probe my handful of features there, and I'm good to go. So I can probe part after part after part with this probe, with this software, and it's very quick. So, but as far as the as far as the live function, that's kind of it. Unless anybody wants to see anything specific, definitely type in the chat box here. If you got any questions, we can get them answered. If not, we'll wrap everything up here. So I'll give everybody just a minute. Let me know if you got any questions. Anything else come through yet?
Nothing yet.
Nothing yet? All right. Probe a plane. I'm just going to probe, we can do any sort of features here. I've got a rectangle. There we go. So we can draw profiles with it. See if we got a rectangular profile. There we are. And then that we could transfer over to a software so that's actually got the dimension of the base. We can do that. We can actually draw. Let's see here. You can draw polylines. So if I do want to trace a line around the part, you know, if I need a profile, maybe it wasn't so square, I can press and hold and do that line drawing. And just trace it around the side of the part. There we go. If I don't come over the edge of it. All right, drag it all the way around. Okay. Now, if you see that, this is why I use more targets than not. If I hit one and I knock it, this isn't a steel part. These are magnetic focal targets, but if I take one away, I'm not down to my minimum number of targets. But let's go ahead and click that checkbox. Zoom up to here, and then now we can see, we can get that profile. Messed up a little bit on the corner, but that's fine. But you can trace profiles with it. You can trace scribe lines, things like that. So let's go to, we'll leave that right there. Anybody ask any questions? We're good to go?
Good to go.
Well, definitely if you got any, if you have a need for a probe or the scanner that you saw for reverse engineering or inspection, again, I'm with Neometrics Technologies. We sell the equipment, we sell the services, so we can actually come on site and do this stuff for you. You know, set up an inspection for parts that you have, or if you got a large part, we can come scan it, provide you the CAD model. You can send small stuff to us that works, and we can take them, we can print them up to a meter on this part, or we can do some pretty high strength carbon fiber filled nylon parts up to about 13 inches, and we have metal 3D printed parts, so we can get you anything like that. So give us a call, 888-696-7226. Go to our website, 3dscanningservices.net. And again, I'm Ken with Neometrics Technologies. Thank you for joining us this morning.